Greetings and welcome, friends. Today we're looking at page 44. We are reviewing solving equations, Algebra 1, big ideas. You guys have been trained with a variety of skills which are going to be excellent for your mathematical careers and perhaps elsewhere. So let's see. Problem 3 here, they asked us to solve the equation, justify each step, check your solution. And so here I've got n is being divided by 5. Could argue that it's being multiplied by -1. To get rid of that, I'm going to multiply both sides by -5. The inverse operation of division is multiplication, and negative times a negative will cancel out, giving me a positive n. So I will get following. So, oh, my mouse tracking all over the place. That's okay. All right. So let's see. These would cancel out. I'd get n is equal to positive 10. Problem. There's a lot more going on. Before I start doing inverse operations, I'm going to want to simplify. In order to simplify here, Austin, follow along. That'd be a great idea. Distribute. I'm multiplying a -4 by this set of parentheses. And so I will end up getting -8z minus 42 minus 12 equals 4. All right, so -4 times 2z was -8z, -4 times +6. This minus sign is still coming with it, is -42. Now I can go through and combine like terms, the ones that are on the same side, like that and like that. Austin, you with us? Like you're not. Well, but you're not paying attention, which is defeating the purpose of it. Just shut off your Chromebook. You won't need it for the rest of the class. Let's see, -42 and -12 become more negative, so that's -54 is equal to 4. And now that I've simplified in the form of distributive property, combining like terms, now I want to start getting z by itself. So I've got z is being multiplied by a -8 and subtracted by 54. I'm sad mapping here. I'm going to add 54 to both sides, like so. And I've got -8z equals 58. Oh man, this isn't going to divide in evenly, but that's okay. So z is being multiplied by -8. Don't try to add 8 to both sides. The inverse of multiplication is division. I'm dividing both sides by -8. I will end up with z equals, it's going to be negative because there's only one minus sign there, and both of those are divisible by 2 anyway. 25 plus 29, -29 fourths, like the best that I can get. Like so. Like so. Yeah, that works out. Let's see, these instructions only applied to the question 3. Let's actually do a quick check. I just want to show you how that works out. So if you do a check, you take the value that you've shown the variable is equal to and plug it in for that variable. So this would be -10 divided by 5. Is that equal to -2? 10 divided by 5 is in fact 2, and it's still got that minus sign. And so cha-ching, it checks out. It checks out. Pretty good, pretty good. All right, so let's so here's like basic solving, right? Inverse operations. We got simplification, all sorts of things like that going. You guys are becoming masters of this. How about question 16? Now, I realize we did not do questions. However, on the test, you do have one like it. So I want to make sure you're all set to do it. And it kind of demonstrates how to do, question 15 that you did do as well. So this one has an absolute value in it. So step 1, what we have to do is isolate the absolute value. It's almost as if I'm pretending this absolute value is my variable, and it's just like a giant x there or something like that. So I'd have -2 times that plus 9. So for inverse operations, I'm going to subtract 9 from both sides. And let's see, I'll have -2 times abs val 5 dubs minus 7 equals, that becomes more negative. That's -16, right? Oh, here we go. The absolute value is being multiplied by -2. So it's illegal to distribute into absolute value. So I will divide both sides by -2. Negative dose. All right. So these would in fact cancel out. I'll get the absolute value by itself. I'll get 5w minus 7 equals negative divided by negative. Oh, sorry, still an abs val. Negative divided by negative is positive, which fortunately we needed. 16 divided by 2 is 8. All right, so now I've got absolute value equals a positive number, or at least a non-negative number, I guess, because it could be 0. And so this so far seems like it's going to work out just proper. Now that the absolute value is isolated, right, by itself on its own side of the equal sign, what we do is we break it up into the two possible cases, all right, for this situation. Either the inside of the absolute value is equal to +8, and the absolute value did nothing, so represent that as such. Or the inside of the absolute value is equal to -8, right, and then the absolute value made it into the +8. So those are the two cases, equals -8. And now I'm going to go through and solve both of these to get w by itself. Add 7, add 7. Hey, happens to be the same step over here, and I already have my second color writing utensil equipped. Might as well keep going. So I get 5w equals 15. Over here, 5w equals -1. Yeah, signs are different. 8 minus 7 is 1. Take the sign of the more influential. Divide both sides by 5. Oh, same step over here. Why not? Why not? So I end up with w equals 3, or w equals -1/5. Throw an or between there. And those are my two solutions. Now, with absolute value, especially if I have a variable outside the absolute value when I had to opposite both sides, opposite this over here, especially then you need to do a check to make sure you didn't end up with an extraneous solution. I believe in this case we're all set. And for sake of time, I'm going to keep cruising. But if you're doing a check, you would just plug in these values for the original w and make sure that the equation all checks out. If one of them doesn't work, you label it as extraneous. All right, here's question 23. This was the boss fight. Woo! Here we go. It says the formula F equals 9/5 K minus 273.15 plus 32 converts a temperature from Kelvin K to degrees Fahrenheit F. Solve for K. So I'm going to have F equals 9/5 K minus 273.15 plus 32. And so what we're doing here is we are solving for the variable K. We're going to pretend as though every other thing in this equation is just a number. So just pretend that F happens to be a number here. I don't know, pretend it's like 10 or something. And our goal is to now isolate the K. All right, now this one's got some decimals and fractions, right? Perhaps you've recognized this number 273.15, I'm sure, right? Yeah, that's absolute zero, my friends, right? My science, yeah, you still am. I think the title remains. Right, yeah, there we go. So yeah, we're doing a conversion formula here. So what we can end up doing to solve for K, I could distribute. I think we'll try to avoid that for now. If I can avoid this distribution into a decimal, but I mean, we've got calculators today. Let's get the parentheses by itself. So I'll subtract 32 from both sides like so. So I'll have F minus 32 equals 9/5 parentheses K minus the 273.15. All right. So now I'm a little bit closer. The parentheses are being multiplied by 9/5. So like I said, we could distribute, and then keep solving, or I can actually multiply both sides by the reciprocal right now. You might think that, well, Mr. Waddy, isn't the inverse operation of multiplication division? And I would agree with you. However, dividing by a fraction is kind of weird, and it's equivalent to multiplying by the reciprocal. So let's multiply both sides by 5/9. Reciprocal, just sometimes I call it the refliprical, right? If we're just flipping it. That's all we're doing. And notice how beautifully this eliminates, right? Just cancels out, eliminates two things in one move, which is pretty great. And we're getting a little bit closer to getting k by itself. Let's see. The classic algebra problems usually is converting Fahrenheit to Celsius or vice versa. The first time I've seen a book do a Kelvin conversion. K minus 273.15. All right. K is being subtracted by that number. How do I undo subtraction by that number? What's the inverse? Your thoughts? Addition. I like it. And I can't just willy-nilly add some number to this side of the equation. I've got to add it to both sides to maintain quality. So I've got add 273.15 to both sides. Now this one I can't combine it inside the parentheses because this one's locked in there. It's being affected by the 5/9. So I'm kind of thinking of adding it just to the end of the parentheses. So 273.15. I will get, let's flip it around all in one go. Let's see, K equals this, right? So 5/9 F Fahrenheit minus 32 plus 273.15 outside the parentheses. And so here is our formula for K. And now the benefit of a formula solved for one of these variables is that I can just plug in a number and get it without having to solve multiple times, right? If I wanted to create a calculator or a computer program that converted Fahrenheit to Kelvin, I would use this formula to plug in when I know Fahrenheit. I would use this formula to plug in when I know Kelvin. And so I can just kind of do the conversion having done the algebra once. Let's do part B here real quick. Let's see, so I'm going to have B, let's see, so Kelvin will equal 5/9. Let's see, we're trying to convert 180 degrees Fahrenheit to Kelvin. 5/9 times parentheses 180 minus 32 plus 273.15. So that's going to equal 5/9. Let's see, 180 minus 32, like 148, I believe. And I think it's about time to reach for a calculadora. Let's see, I will do 148 divide by 9. Yeah, that's a decimal. Times 5. I get 82.2 repeating plus the 273.15. And I'll get Kelvin equals, add those two numbers together, 7, 5, and I get 355.37 degree. Nope, actually I think it's just no degrees. I think Kelvin is just, although that's actually quite a hot temperature. At least, I mean, I wouldn't want to ever be 180 degrees myself. All right, so thanks for watching, internet friends. Hopefully you have a great bye-bye.